regulatory maze can be overwhelming, especially when dealing with waivers and NAA-specific rules for dock operations in the EU. You've got the STS, the PDRA, the SORA, and within SORA, there's air risk mitigation, ground risk mitigation, sail determination. It can feel like an endless list, right? And you're probably wondering which of these would apply to our dock-based operation. Well, we have a special guest from DJI who's here to break it down all for you. So if you are feeling like this, he's going to guide you through step by step on what you need for your dock operations to get started. With a degree in automation and mechanical engineering from BMSTU, he serves as the DJI Enterprise Solution Engineer for the Southern Europe market, focused on commercial drone applications for public safety and energy industry. Throughout his tenure at DJI Enterprise, he has gained vast experience in drone rescue missions and asset inspections from China and different European regions. So please join me in welcoming Irving. Hi, Irving. Welcome to the show.
Hello.
All right. We warm welcome to you, Irving. We are also joined by Havish, one of our product managers at Flightbase. He's here to share the features and integrations Flightbase as a software platform brings in to make the approval process seamless. So grab your cup of coffee and let's get to it. This session is being recorded and we'll publish it for online viewing soon. Please feel free to drop your questions in the Q&A section or the chat window, and I'll try to get them addressed from the experts at the end of the session. So with that, I will pass this over to Irving.
Okay. Thank you, Vasily, and to join the webinar. Let me go ahead to share my screen.
Yes.
Okay. Can you see my screen now?
Could you please go to the presentation?
Yeah.
We can see the current screen. Do you want me to share it, Irving?
Yes. Maybe better.
Yes, I'll do it.
Okay, perfect. A quick introduction of myself. My name is Irving from DJI Enterprise. I'm solutions engineer dedicated for DJI Dock products, and now we are doing a lot of marketing developments in European markets. I believe a lot of our friends today in our webinar are also working on, let's say, the future of drone technology, DJI Dock. So the docking system is actually an automated solution where we can automatically to launch the aircraft, do the mission, capture the data, then return to home, charge back and solve everything automatically. But for those kind of automated solutions, we are facing some, I would say, the challenges from the legislation side, especially in European markets. Currently, the dock operation, which is like we don't need a pilot on the site, will be considered as beyond according to EASA regulation, which is, I would say, a little bit headache for, I believe, all of DJI dealer, all of the dock service provider in the markets. I believe that's also the one of the important reasons why the topics are always very sensitive and interested from the market. So today I will share some content, especially some like information regarding the regulation and DJI to support markets. Okay, so let's start from the EASA regulation. So basically, EASA, as European Aviation Safety Agency, they try to divide all of the drone operation into three major categories: the open category, specific category, and certified category. So basically, certified category is more for the managed aircraft, the helicopters, I would say even the fixed wing or some landed aircraft. So today maybe we'll mainly focus on the open category and specific category. there are several important conditions to define if your drone operation will fall into open category or specific category. So first of all, we need to limit the drone within 120 meters, not too high, which is risky mandated aircraft. Second, we need to have all of the drone C class label certification of the drone itself. For example, now we have for Mavic 3 Enterprise series for C2 and Matrice M350 for C3. And currently we are also working on C6 label for DJI Dock 2. Yeah. So if the drone is not carrying any C label, it will be fall in specific category. Okay, and we should always keep the drone operation within visual line of sight. If the drone is flying beyond visual line of sight, which is, I would say, the common use for DJI Dock 2, it will fall into specific category. Yeah. So maybe next question is why we always want our drone operation falls into open? Because in the open category, we actually don't need a special permission from the National Aviation. But if the drone operation falls into specifics, we actually require to obtain an operational authorization from National Aviation Authority, which is quite difficult. For example, if you want to deploy a Dock 2 into your customer site, if we can do like the drone operation in open category, it will require very simply like you just deploy the Dock, plan some mission with FlyHub 2 or flight-based platform, and continue the work like drone operation. But for the legislation concern, if the operation falls into specific category, usually you need to prepare a big amount of documentation, which we're gonna talk later, and handle them to your National Aviation Authority. Then waiting for them to give approval, it usually takes like, I would say, 2 months to a year could be. So that's going to be our headache in some of the country. Are being, I would say, a little bit tough to give this permission. Yeah. Okay. Yeah. Next slide. I will talk about more. Yeah. Talk about more of the open category and specific category. As I just mentioned, there are actually several defined conditions if our drone operation can fall into open category. If we didn't meet one of those conditions, the operation will be categorized specific. As I just mentioned about CX label, the drone should less than 25 kilograms. The operation should be less than 120 meters and not over people within a visual line of sight, no dropping payload and so on. Okay. Next, I want to share is about subcategory. Actually, beyond the open category and specific category, they could be divided even into categories. A1, A2, A3, and STS1, STS2. If out of those, I would say the standard scenario, we will need a SORA or PDRA or even a look holder to process the permission, which we're gonna dive into deep later. Okay. Yeah. So next slide, we're gonna start from easy open category. Okay. So we have 3 subcategories in open category: A1, A2, A3. So basically, the difference is about how close the drone is to the people. If we want to fly over people's head, like I would say the crowd or a lot of people, there's a lot of technical requirements for the operation in this scenario. Yeah, we need to have the C0 and C1 label on the drone, which is, I would say, the DJI consumer drones. And the pilot also need to have training, like read the menus, and obtain A1, A3 license. I would say the A1 sub-scenario have the most flexibility of drone operation, but I would say it's difficult to reach the technical requirements. For example, the CX label, they will need the drone actually like very, very light, very small, very portable. But enterprise drone the weights. Okay, and for the A2 scenario, we can fly closer to the people, like 5 meter to 30 meter, depending on your flight speed. A lot of our DJI drone customer, they are doing surveying. Surveying actually flying very, I would say, fast, like 12 or 15 meter per second. And if you want to do a 3D model of city or let's say the church, I would say mainly to yeah, in the open category. The requirement for A2 is also similar. From the drone, we need a C2 label like DJI Mavic 3 Enterprise or M30 series. For the pilot requirement, we need to have A2 license. So next it goes to our A3, which is out of the city. Where it's like very few, very, I would say there's nobody, and under your operational volume, there's not like uninvolved people in the S3 scenario. And the technical requirement is for the C3 label and C3 label like M350. And for the pilot training, it's required to have A1, A3 license. Yeah. Okay, so that's basically about open category. From my marketing investigation, I would say the enterprise customer, the enterprise professional drone user, the good business maker cannot. I would say cannot operate in the open category, so we still need a like special permission in a specific category. Yeah, if you could. Okay, in the specific category, EASA provide two standard scenario, which is STS1 and STS2. Those two standard scenario, EASA already pre-defined the risk, so we just need to follow the rules. We don't need to define the risk, do the risk assessment again. So for the STS1, it's mainly to pilot the drone in the city or let's say in some of the no-fly zone. We still need to keep the drone within visual line of sight. The operation should be still limited in 120 meters. We can fly in the urban area, but with no uninvolved people. The limitation is we need to have a C5 label. Like from my understanding, there's actually two kind of C5 version of M350. One provided from Flying Eye, one of our DJI partner, and another from Dronavia. They are actually adding the 50, which could be considered, and they self-declaim that it's a C5 label could be used in STS1 scenario. Okay, also for the pilot training requirement, we will need a STS certification. It's actually STS1 certification. Okay, then goes our next. It's closer to the dock, STS0, because the site. We can operate the dock in STS02 with a visual observer, with a guy on the field to monitor if the drone, if there's any potential air risk, like some helicopter or manned aircraft passing by. Okay, but now could be an obstacle is about the technical requirement. We are now working on the C6 label of but currently the progress could be a bit slow, and we are cooperating with a third-party accessory to get this certification. So if you, I will still need your gentlemen's a little bit wait. Yeah, till end of year we're gonna provide a C6 version of Dock 2. Yeah, also for the pilot training, it's required to have a STS2 certification. Yeah. Okay. Basically, that's about standard scenario. I would say it's not that flexible to operate freely about like fully automated solution like Dock. We actually, I would say now currently the technology is a little bit beyond the regulation limits. We actually did a lot of pressure test, safety test before we provide the product to the market. But I would say in the like according to the regulation, is still need to be tested from the documentation side, from the on-site experimental test and so on. Okay, then we will talk about our today's main focus, the SORA. If you could move to next slide. Oh, thanks. Yeah, so SORA, it's specific operational risk assessment. Why we need it? Because our operation is not in the standard scenario. It means the risk was not predefined by the government. So we need to prove we can fully control. Wouldn't say the fully control. We can provide a documentation to the government to show them, okay, I know all of the potential risk. So SORA is actually a risk assessment methodology to classify the risk posted by the operation in specific category. Currently, we have seen actually many dock permission from different countries, Czech Republic, from Germany, from Italy, most of the operational authorization was come from SORA. So actually, specific operation risk assessment is a more efficient and practical way to get a permission to fly a automated solution like Dock. So these slides, I will briefly introduce how SORA works. So simply speaking, talk about two small topics: air risk class and the ground risk class. Air risk class basically means that we need to always put the drone, limit the drone away from the manned aircraft. So ground risk class it's mainly about we should keep the drone away from the people or I would say a lot of people, okay, away from the crowd. Okay, to limit the drone, so we are introducing another, I would say, the system about geocaching. We want to limit the drone operation in our flight geography. If the drone in any, I would say, the worst case, like the loss of GNSS signal or like very strong wind, if the drone is flying out of the graphic, which is the green zone on the picture, will need to start the contingency procedure. And the drone in the contingency volume, we will need to find some way to limit the drone. Like a flight termination system, or return to home, or fly to a safe altitude, or another like actions. If the drone is even flying out of the contingency volume, we will need to start the emergency procedure. But in all-in-one is always keep the drone from the manned aircraft and the crowd. So that's basically the logic of the SORA. Next, I will deep dive into several important steps of SORA. If we could move to next. Yeah. Okay, about the big documentation, how we organize it. SORA is actually a 10 steps methodology. Here I will highlight seven main steps in the SORA. So the first step, the columns configuration. We will need to define the mission type. Is it beyond visual line of sight? Is it is there a visual observer on the site? Is it like within the visual line of sight? Mission type, and where are we gonna do the mission? Like exactly location and how we gonna do the mission? We're gonna fly. We're gonna have a visual observer on the site. We're gonna pilot from a remote piloting center. How we gonna pilot? And what we're gonna do it, and some more technical information of the DJI product, like DJI Dock 2, and of course of the software features, like all in total to provide a comprehensive technical info. I would say this is a very big documentation of the columns, defining the location, defining the technical info, and a lot of the like small basic components. Yeah, so that's next, we're gonna analyze the ground risk class. There are several factors to define which ground risk class we can fall into, which I will dive deeper in next slides. And next step in the ARC, air risk class, also similar logic. So when we have the ground risk class and air risk class, we can cross-check and have the final cell specific assurance integrity level in the cell table. Then the cell is more like an indicator to show how risky our operation is. Could it be the low risk? Could it be the medium risk? Could it be the high risk? Then, according to how risky our operation is, we will need to fulfill the OSO. We will need to meet the requirement. OSO stands for Operational Safety Objectives. There are actually in total 24 objectives. Each of them we need to fulfill, but they have different robustness depending on the different cell. Okay, which we're gonna dive later. Yeah, if we finish all of the those contents, then we goes to containment. Containment basically is about limit the drone in the operational volume. There are several ways to achieve it. For the basic containment, we can provide a possibility of UAV to leave the operational volume. Also, there are another, I would say, the physical way to limit the drone, like flight termination system, which I'm gonna introduce later. So if you finish all those steps, congratulations, a big and very good documentation you prepared. Summarize all of them and submit to your National Aviation Authority. And after several days or weeks, depending on the agency efficiency, we will have the operational authorization. So that's about, I would say, the overall roadmap of how to do a SORA. Then I would like to highlight several points today to introduce more, like deeper of how it looks like. So for the GRC part, there is actually a table, as we can see here in the screen. We can define, or like by defining the dimension, how big the drone is, we can and like how the kinematic energy, if the drone falls to the ground, how many energy it can cost, and how densely population you have under your drone operation, and do you have a visual observer, and like for I would say factors, you can define your ground risk class. So here I want to highlight is about DJI Dock 2 is falling to actually the first column. Our dimension is smaller than 1 meter, like in this way, and yeah. So basically, it's depending on how many people, how crowd you have under your drone operation. Okay, that's about initial ground risk class. Also, we have several ways to mitigate the ground risk class. For example, the ground risk buffer 1-1 rules. If you can limit your drone away from the city, from the crowds, following the 1-1 rules, if you could integrate another parachute system with Mach 2512 like compliance, it will be considered as medium M2, medium robustness, and we will have -1 in the ground risk class. Okay. Also, if you could provide a good documentation of emergency responsible plan. If the drone have any bad situation, like flying automatically out of the operational volume, which is very seldom happening, I will explain later. If the drone is crashing somewhere, hitting some assets, even hurting some people, you have everything planned and good documented, and provided to the government. Okay, yeah, according to my investigation, the parachute here could be a very good and efficient way to mitigate the ground risk. And also the emergency responsible plan is, I would say, even mandatory to have. Okay, that's about the ground risk. After the mitigation, we're gonna have from 1 to 8, and maybe some mitigation like 1, and we're gonna have a final number to indicate our ground risk class. Yeah, so next slide is about, yeah, okay, thanks. So next slide is about air risk class. We also have a very good table to define by the flight altitude, airspace traffic, and so on to define your air risk class. I would also walk you through about the procedure. So we start actually from the top and the left. like the green triangle. Okay. So the first condition is if the operation is in atypical airspace. What is atypical airspace? Basically means like 30 meters above the ground or 30 meters above your assets. As we understand, it's actually difficult to limit our drone only in 30 meters. We cannot do the surveying, we cannot do the map, we can only do some like security patrol, which is very big noise with it. So I would say it's difficult to like limit your risk in Arc A. Okay, but if you didn't meet this, no problem. It goes to next one. No, if the operation is bigger than FL 600. FL 600 basically means like 30,000 feet, which is super high. Operation is not meeting this. So then goes to the no. Operation in airports, basically, I believe most of the DJI Dock operation could not be used near the airport. So I would say the answer is no. Then goes to next one. Operation is bigger than 500 feet, but smaller than 600 feet. Basically, if we can limit our drone within 150 meters, we can have this. So next question, the operation is smaller than 500 AGL is similar. If the drone can be limited, can fly lower than 150 meters, we can meet this requirement. Then goes to our main steps, the 3 steps, which is limiting the drone operation a lot. First, cannot operate in the TMZ. We need a transponder to always call the coordinate with the manned aircraft. Could be difficult. If we force into ARC-C, later in the cell table, it will be difficult to like coordinate. So next, the condition, the operation in controlled airspace. If the dock will be operated in the controlled airspace, I would say the air risk class will fall into ARC-C. Also in the cell, it will fall into at least 4. Yeah, if you could move to next slide. I want to hear like quickly highlight about here. If the residual air risk class falls into ARC-C, which is the blue in this table, at least we're gonna have the 4 as cells as a cell. If we fall into like cell 4, the OSO will be very difficult to meet the requirements. I wouldn't say it's recommended to force into cell 4. Like according to our experience, we have seen like most of the dock permission was given in the cell 2. Okay. If you could turn back to last slide, please. Okay. So next is in uncontrolled airspace and not in the urban area. Unfortunately, we still like need to follow the procedure. We cannot operate in the urban area. Then goes to our final, I would say, the target risk class. In the last column of this table, we will fall into ARC B. Okay, the target risk class. That's actually the initial air risk class. Also have several mitigation, like DJI Dock 2 is carrying ADS-B sensor, which is receiving the broadcast from the manned aircraft about their location, about time and everything. Yeah, ADS-B could be a mitigation. And if you could like always away from the manned aircraft, leave a buffer distance like from the manned aircraft space could be a good mitigation. But according to my investigation, currently there's actually no effective in the markets. I hope in the future we're gonna have more and more UTM service provider like USSR in the markets. We can have more detect and avoid equipment on the market, so we can do more integration and have good cooperation to provide an even safer operation, especially in the air class. Yeah. So if you could move to next one. Yeah. Please the cell. Last one. Okay, great. So next we're gonna have the final GRC and the residual ARC. There's a cell table help us to identify how risky our operation looks like. Okay, so the green, blue, and the red actually stand low risk, medium risk, and high risk. If we have the final GRC, let's say 3, and the residual ARC, let's say ARC B, we can have cell 2, which is I would say the common cell for Dock 2 operation. Okay, next please. Okay, so from last step, we have cell 2 as I would say the requirement. Next, in the OS operational safety objectives, we need to strictly follow the rules. We need to meet the requirement provided from EASA. So if the risk level falls into cell 2, we have a 24 OSO in total to meet, but some of them is optional, which is like the letter O, and L stands for low, and medium, M stands for medium, of course. And for those for those OSO, we can roughly consider them into 2 parts. The OSO to the manufacturer, it's mainly about drones, about the technical info of the drones, and maybe some third-party payloads and FTS, the technical info, and some safety features like Flightbase are providing a lot of interesting features which we're gonna talk later. Yeah, those OSO are to the manufacturer to describe the product is designed safely. And also we have several OSOs for the will we need to fulfill by the operator. About the procedure management, different procedure, about the training, about maintenance, about certification, about your organization structure, and yeah, there's a lot of OSO for the operators as well. So what we are doing from DJI is like we're providing all the documentation for manufacturer, all the OSO. So as we can see here, the OSO 2, 3, 6, and I will not list all of them, are provided by DJI already, and we already meeting the cell 2 requirement according to this table requirement. Okay. So and we're gonna provide it later in next few slides. Yeah, please next. Yeah, so next step comes to the containment. The containment is the main idea is drone shouldn't leave the operational volume. Okay, should always stay in the area where we plant. There are 2 efficient way, I would say. First way is to simply use a parachute. We can put a parachute on the flight termination system on our battery. So it's more like a component where we can cut the battery. When we cut the battery, the drone will automatically falls and trigger the FTS to limit the drone operation. I would say it could be a little bit risk if the drone directly falls. So it's always recommended to carry a parachute at the same time. And another way to achieve this containment is to have a possibility of UAV to leave the operational volume. From DJI, we are providing a manufacturer declaration to declare the Dock 2 is a safe product. The rate of Dock 2 to leave the operational volume is quite low. We've been testing actually each of the Dock 2 more than 300 flights before we launch the product. Only when we have all the tests done and everything goes smoothly, not only about pressure tests, also about waterproof, also about dust proof, about vibration, about shaking, about arms, about wind resistant test. After all of this test, we're going to provide a product to the market. So I would say the product was designed safe, and we provide this declaration from manufacturer as a good documentation to prove the safety. Okay, so that's about containment. Necessary steps. We are very close to have the operational authorization. And here I want to highlight one point: as SORA is more like a SQ on top of the SQ, we can see the SORA documents. But actually, they require a lot of more documents under the SORA, which we cannot see. We need to have a SORA as I would say, the leader of the documents to link different part of documents. It's including the ops manual, the maintenance manual, the emergency response plan, and a lot of big documents. So maybe some of the audience would say like, okay, the regulation is full of paperwork. I would say we need to use a safe product. We need to prove us it's a safe product. Also, we need to use it safely, and good document all of those things. Okay, so next slide is about DJI documentation support. So from DJI side, we know our product very well. I gathered many development guy to ask about like all of the very deep information of our product to create a big documentation, and we provide it free of charge to the market. So based on the EASA template of ops manual, last one. So based on the EASA manual, we create a template for ops manual, and in this documentation we create a SORA template and SORA compliance of requirements with all of the OSO, and we have some product functional hazard assessment report and manufacturer declaration as I in the last few slides, and the robustness report for DJI Dock 2. Also, of course, providing the user manual, maintenance manual, and so on. Yeah. Okay, so next question goes to how to download it. Next slide. I put a QR code here. If you could scan the QR code, there's a quick survey. We want to understand who is using the documents. And provide a quick, I would say, the advice, which process to go with. And then you can download the documentation, everything I listed in last few slides. Okay, besides the documentation, if you could move to next one, please. Okay, besides the documentation, we also planned several actions. We had a documentation ready in August, and we had few DJI dealer training in September, and we posted several blogs to guide the regulation in Europe. And we had several webinars. We had several like explainer video posts. Now we are having our interesting webinar with our partner Flightbase to introduce all those regulation to the markets. I want to, in end of my sharing, I want to say like regulation is not a black box. It's about safety. And from DJI side, we are also optimizing our product to design it even safer. In the future product, in the software features and everything, I believe in the ecosystem partner, there will be more and more UTM service provider and DAA detect and avoid system coming onto the markets. Also, I think the regulatory, the government are also optimizing the regulation. So in the future of the dark products, dark markets, I would say it will be better and less pressure. Okay, that's pretty much from my sharing. I believe next one. Next, I will have our partner to share more interesting stuff for the BVLOS operations.
Thank you so much, Irving, for walking everyone through giving everyone a very detailed overview of what the EASA regulations are and how can they get started with dock operations. Congratulations on the fact, exciting news that the M3D and the DJI Dock 2 will soon have their own Class 6 label. Again, thanks for highlighting how can they exactly go through the different processes, right from the ground risk to air risk to sail determination, the OSO and the containment to go and get their BVLOS approval. and also for giving the walkthrough of the documentation. So if anybody would like to get their hands on the documentation, we can drop the link to the website as well, and share the QR again at the end for you to go ahead and get your hands on these documents that DJI has meticulously prepared. Moving on, I would now like to invite Havish, our product manager, to talk a little about what Flightbase is doing and what kind of features and integrations are Flightbase building to help you with these BVLOS waivers and approvals. So over to you, Havish.
Thank you, Vaishali. As Arvind said, this is all about safety, and the product needs to be certified from all directions, and it needs to be safe from all point of views, not only just the hardware, but also the interface that the user is using. And like Arvind mentioned, the partner ecosystem and basically the product ecosystem are going to be bringing a lot of products like the detect and avoid and UTMs and such solutions to make your air risk low and your ground risk low, right? So how does a flight operations platform augment this? Why do you need a platform that is also similarly heavily tested? It's certified, and it also covers everything that something like SORA and ConOps will require you to present to the regulations. So we'll start with a few key features of Flightbase. So the first one is the pre-flight safety checklist, which a remote pilot would go through before they launch a flight. So it covers a lot of the important things that they need to check and ensure that it's good, that the flight area is secure and the flight is going to be secure before they fly. In case the user is using automated flights, then there are safety systems in check which would not let the drone fly in case any of the safety issues the safety conditions are not met and the area is unsafe. Going to the next one, we will start now talking about how to mitigate ground risks at your area of operations. So the first one is, I believe, geofences and no-fly zones. So this is essentially the operational volume that you have to limit on the device. Flightbase provides a very intuitive UI for you to define that operational area, which is then transferred to the drone. And we are currently working with parachute manufacturers to transfer that same operational volume to the FTS system, which comes with a parachute. So if for whatever reason, the drone is unable to hold itself inside the operational volume, because the parachute and the FTS system have their own independent GPS, the FTS system would deploy and the drone would come to the ground with the parachute. So this is a requirement of MOC 2512, which Flightbase is working very closely to ensure to give the user a very intuitive UI to configure not only the FTS system, but also the parachute, and the ground risk. The geofence around the drone. Yes. Okay. Going next, we have the dynamic path planning. So basically, if you define no-fly zones and you define geofences, the drone cannot go outside of a geofence, and at the same time, it cannot enter a no-fly zone, which means wherever the drone is currently and wherever it needs to go, it needs to chart a path which avoids the no-fly zones while staying inside the geofence. So on the Flightbase dashboard, you can see how the drone is doing it, and you can be rest assured that all the operations of the drones respect these boundaries that do not leave a geofence while do not enter a no-fly zone. Okay. Going forward, so this is the parachute integration that we were talking about. Currently, we are working with partners like AVSS and DroneAvia. So the parachute from AVSS is ASTM certified in the US, and they're currently working on the MOC 2512 certification to fly in the EU region. And I think the same goes for DroneAvia too. I think they will be out with the product soon enough, so you can use these to reduce your ground risk. Right. Going ahead to mitigating air risk. So we have, I had mentioned in the beginning, DAA systems are very important to basically let the user know about their airspace. And for this, DAA sensors are the key, which is detect and avoid sensors. Now, detect and avoid sensors are able to gather data about their airspace from a lot of different kind of, receivers. They have radars, they have visual detections. Sometimes they are mounted with cameras that use deep learning models to detect any object in the air. They also have ADSB receivers, and they also have remote ID receivers. So the user on their dashboard can see not only their own drones, they can also see drones flown by other operators. They can also see cooperative and non-cooperative aircraft, and basically they have a complete you know they have a complete visualization of the airspace on their flight-based dashboard. So using this information, they can make very informed, safe decisions as to when to fly the drone, when to bring the drone back, and be very careful as to not affect safety, right? This again helps with the ARC and the OSO of the complete product that the people will be using, which is the dashboard plus the DJI Dock 2. Okay. So some of the sensors that we are going to be integrating with is, D-Drone, Avionics, Senhive. These sensors, again, like I said, have different kind of receivers which are able to detect different kind of aircrafts in the airspace. Okay, so moving on, go to safe altitude. So let us say one of the sensors, one of your DA systems was able to detect a commercial aircraft in vicinity of your drone. What would be the safest thing for your drone to do? Landing is not really an option because you might be flying over a place that is not very suitable to land, but there's always a safe altitude that you can drop down to let the aircraft pass. So for this feature, we call this go to safe altitude. The user has a button on the dashboard, which as soon as they trigger, the drone will drop from its current altitude to a predefined safe altitude, and it can wait there until the commercial aircraft can pass over them. And once that is done, the user can resume the operation that they were doing with their drone. Flightbase is currently working on automating this whole process where, even if the user, if the user has completely automated all of their drone operations, then Flightbase would take care of doing this on its own, depending upon whatever air risk it is identifying through its DA sensors. Right. The next feature is beacon. So a beacon is very important because in low light conditions, it's very difficult to identify a drone in the air. And people on the ground, as well as people who are flying aircrafts, would be really, they would not be able to see a drone without something like a beacon on top of the drone, which would be very bright and which would be very easily identifiable for anyone. So a beacon is again very important for visibility of the drone to all other parties other than the person who's flying it. Then we have UTM Exchange. Again, UTM Exchange really helps with ARC, like Irving mentioned. Flightbase is building the standardized APIs to help bring different UTMs in different regions integrated with Flightbase. UTMs would help the customer in a lot of different ways. One, they would do deconfliction for us. So when you apply for a flight, the UTM service would check if there are any other flights which are planned in the same area and would be able to give the user a go or a no-go depending upon the situation. And even when the drone is in the air, UTMs would also be able to provide us information as to is there a rogue aircraft coming into our area, or has anything changed in that airspace, due to which the drone would need to be brought down, like in a GTSA format, or just brought home, like come back to the dock. So UTMs are really useful for providing all of this airspace information, and they are going to be varied in different regions. So Flightbase is trying to build the platform that would help bring all of these different UTMs on the same dashboard for the single user. Right. And the last is, and the next one is, the robust alerting system. So if any of these safety incidents do happen, then Flightbase has a very good UI for informing the user of something like this happening, and grabbing the user's attention and helping them resolve these situations as they happen real time. So moving on, we know that with a product like Dock 2, people are not going to be deploying one dock or two dock at any of their sites. People are going to be deploying many of them. So when a user has to interact with many docking stations or many of these products at the same time, the interface for such a operation has to also be scalable, in the sense that interface should be very good to work with even with a single dock, and the interface should be very good to work with even with multiple dock. So the same goes for safety too. The interface should be safe for one dock, it should be safe for operating with multiple docks. So this kind of operation where you have one remote pilot who is operating multiple docks, we call that as one-to-many operations. And for a one-to-many operation to be safe, there are mainly three elements, which is visibility of that one-to-many of that fleet of operations. The second is fleet control, which is an easy way to control all of these different docks which are operating. And the third one is automated fleet safety. So we'll go through them one by one. The first one is visibility. So in visibility, we have the video wall. So what a video wall does is that it gives the user a very quick view as to what each drone is doing. The video wall captures information like who is flying the drone, like which remote pilot is flying the drone, and what is its height, what is it currently doing. And in case any one of the drones is facing some kind of a safety issue, then it is very well highlighted and the user can clearly see what the safety issue is so that they can go and address that particular drone independently. The next feature is operational notifications. So this is when all the flights are automated. If any, again, safety issue occurs, then the users would get an email on their phone, on their laptop, and which they can use to understand what is the safety issue happening with which particular drone. And there's a quick link called as view operations that you can press to quickly go to that particular drone's operations, and then you can take corrective actions to handle that safety incident. Moving on, you have fleet controls. So fleet controls is basically where the user can select multiple drones at once and issue them the same safety command. So for example, the weather deteriorates and you have 3 or 4 drones which are flying in the air at the same time. What you can do is you can select those 3 or 4 drones and you can just press one button like RTDS, which is returned to docking station, and all the drones would start returning to the docking station at the same time. So this reduces the user's cognitive load trying to navigate between the controls of each of the drones individually, trying to have a single visibility of each, not having that visibility of all the drones at the same time. These kind of controls, this kind of safety solutions really help with the one-to-many use case that the industry is going towards. Then we have automated fleet safety, so deconfliction. Now, like we had mentioned before, UTMs would be there to help with deconfliction, but Flightbase is also building its own deconfliction services, which are going to help with areas where there isn't an UTM or if the UTM is not sufficiently developed enough. So in our own deconfliction service, what we're going to be doing is that when the user uses fleet controls where multiple drones are being controlled at the same time, Flightbase is going to be doing strategic and tactical deconfliction. So strategic means before even the drone flights, you're going to check if the drone's flight path is going to coincide with any other drone's flight path and let the user know before even the flight that this is probably not a safe operation. But in case the drones are in the air and then they get into a scenario where they might be close to a collision, then the Flightbase deconfliction service would stop the drones and then it would inform the user to take physical action, or basically inform the user to manually take decisions on how to bring the drones apart and bring the drone home. So this would be something that is again very important in one-to-many use case when there's one user and multiple drones. Right. Going forward, this is the last feature, which is basically the logs export. So you have done a lot of flights with Flightbase now, and there's a good repository of safe flights that you have done, which may be something that your local regulations may ask you to prove that, okay, so you have been operating for the last month. What are your safety stats? How many flights have you done? How safe have each of those flights been? So to help respond to regulatory requirements like this, Flightbase has the ability to export all of your flights in a CSV manner or a GUTMA file format, which means if you were to export it in a GUTMA format, then there are a lot of third-party solutions out there which help with logging your flights and logging the operators who flew that flights. So we allow this accountability, auditability of your flights on the Flightbase dashboard. So with all of these features that we have right now, the ones that I have talked about and everything that we've discussed before, Flightbase and its customers have been able to get BVLOS approvals in over 10 countries until now, and it is in different applications like solar farm inspection, pipeline, thermal power plant, and so on and so forth. So that's it about from Flightbase. Vaishali, over to you.
Yes, thank you so much, Havish, for walking everyone through. For people who were also listening in, for the flight logging, we are right now working closely with Drone Logbook and Air Data. So if you are using these applications, you would be able to export your flight logs to these applications as well. And yep, we don't have a lot of time left, but we do have lots of questions. So I will quickly jump into the questions. Quite a few of them for Irving.
Okay.
Havish, can you please mute yourself? There's some background information and noise. Sorry. Yes. So one question is what you mentioned, Irving, is mostly around the doc two. So what about doc one? Will this be applicable for?
Okay, so for DJI Dock 1, currently we actually don't have the plan to do the C label. Yeah, currently we are still dedicated all of our manpower and resource on Dock 2 integration with a third party, and we're gonna have the certification this year. Yeah.
Okay. And there is one question which is you've already covered that the DJI is working closely, but because of the C6 label, there is going to be an FTS required. If you would want to reiterate how is DJI going to provide that?
Yes, so we are working closely with one of our partner to provide FTS and parachute system during the C6 project. And before we handle their solution into the company who can give us the certification, we also had several internal tests of flight termination system and the parachute. After 3,000 flights and several pressure tests, everything's down the way to the party certification company. Now it's in the procedure, and I believe the end of this year we're gonna have a co-solution between DJI and our partner. Yeah.
Okay. That's great news. There's also a question around the SORA 2.5, which is going to be adopted and implemented in either Q4 of 24 or Q1 of 25. So how is that going to affect Dock 2, or will it be similar in process to what it is right now?
Yeah, sure. 2.5 is a very good point, but it's keeping delay and delay. It's actually EASA told that could be published last year, and like everyone should follow 2.5. But to end of this year, still no like certain news. EASA will adapt it from JARAS. Of course, we did many search and keeping very close touch with both party to understand the new 2.5, how it will affect the dock operation. I would say it will be not easier. It will be more clear about technical requirement for the manufacturers. And so we are working closely to meet the requirement for 2.5.
All right. There's also a question around sale. So what is the maximum sale for which DJI Dock 2 was approved? Is it sale 2 or more? I think you've covered that already, but if you could reiterate.
Yeah, cell 2 actually. Yeah, cell 3 is I would say there's no like clear description, clear OSO for cell 3 from EASA. So if there's no rules, we cannot meet the rules. So currently the maximum is cell 2.
Got it. Thanks, Irving. I'll also take a few questions for Havish. So, Havish, there's a question around DAA. So, does it also see manned aircraft? So, maybe you could talk about the partner DA, which also sees cooperative, non-cooperative aircraft both. So, yeah.
Sorry, what do you mean by Cs?
So, do they detect manned aircrafts? Is the question.
Yeah.
Yeah.
So basically, manned aircrafts are divided into two categories: cooperative and non-cooperative. So in cooperative aircrafts are the ones which have the ADS-B transmitters, and basically you can receive the data over a wireless technology, and you can see where they are, where they're going. So there are a lot of DAA sensors which have ADS-B receivers. Even the DJI drones themselves have them. It comes with a feature called as DJI AirSense, right? And for non-cooperative aircrafts, you usually need to use something that has like a radar or that has a visual detection system, like an array of cameras. So different DA sensors provide different capabilities. And all of those detected sensor, or all of those detections can be brought on FlightWays through the DA integrations that we do.
Yes, and there was another question around, so what type of law enforcement or public safety solution does FlightWays offer? So if you could maybe highlight a few features around our public safety operations.
Right. So one of the common requests from public safety is an integration of a CAD system. CAD system is basically computer-aided dispatch. So that is the system that is used to usually respond to like 911 calls. What we have is an integration with CAD systems. So if you know the location where that particular call came from, then you can raise an alert on the FlightWays dashboard, and a drone can automatically take off from a dock and go to that location, or it can be sent by the user manually. So that is just one of the most important features around responding to basically drones as first responders, or basically for police requirements. The other feature that we're recently bringing is basically object detections and AI detections on the video feed of the drone, where we can detect people, we can detect vehicles, we can also read license plates, things like that, which are also very useful in these kind of scenarios.
Right. Thanks, Avish. I think we are out of time now, so we have a few other questions which we will also pass it. If it's for Irving, we'll pass it over to Irving to answer it for you, and as well as for Havish, we will try to answer them in a sync mode shortly. But yeah, I think it was a great webinar. Thanks again, Irving, for sharing so much information around how people can get their waivers process simplified with the Dock 2. And there's exciting times ahead, and there's lots happening in this space. So do you have any closing thoughts before we end the session?
Well, I would say, like everyone understand, the dock is the future of the drone technology. But I believe all of the audience who are joining us today is the guy who will make the future happening. So let's work together. We're gonna, from manufacturer side, provide more and more safe products. Also, the audience, like from the market side, we're gonna promote it and give more and more approval and have more discussion with the regulatory, like governments, and to optimize this situation. Yeah.
Thanks, Irving. And for everyone asking if this session is going to be available for viewing later, yes, we are recording this session and it is going to be available for online viewing later. We will also send the link to the webinar recording to you shortly. And yes, thanks again, everyone, for joining in. I hope you had a great time and it was very informative for you. Until the next episode, see you again and have a great day.
Okay. Thank you, guys.
Thank you. Thank you guys for attending.
Thanks.
Bye-bye.